Hi, Assalamualaikum warahmatullahi wabarakatuh. In this video, I'm going to give you more examples related to higher derivatives. Well, here we have this function. You are asked to find the first, second, third, fourth, and nth derivative for n greater than 4. So we're going to start off with finding the first derivative, which is y prime, and this is equal to differentiating this function one time, and the result is going to be dx. We have the function x cubed minus 6x squared minus 5x plus 3, and so you will have, if you differentiate this, you will get 3x squared minus, for this one here you will get 12x, this one you will get negative 5, and if you differentiate constant, the answer is going to be 0. So here we have the result for the first derivative. Now the second derivative is just applying this result to the process here. So we're going to use the result here and differentiate it once again, and the result is going to be, for this one is going to be 6x minus 12 minus 0. So differentiate the constant, the result is 0. Now for the third derivative, we are just going to apply the result here. So this is the second derivative, the result of the second derivative. We're going to use this result and differentiate it once again, and the result that you get is going to be equal to 6. Alright, now let's talk about the fourth derivative. So the fourth derivative means we are going to differentiate the result of the third derivative, which is equal to 6, and the result here is going to be equal to 0. So since this is also a constant here, you will imagine that if you want to differentiate or this function again, or if you want to find the derivative for the next one, for example y5, the answer is also going to be equal to 0 because this is a constant. Differentiate it is going to be 0. And if you want to find what is the sixth derivative, it is also going to be equal to 0. So therefore the nth derivative for this function is going to be equal to 0 for n greater than 4. Okay, so for n greater than 4, such as 5, 6, and so on, the result here is going to be equal to 0. So that is the answer to example 3.17. Now let's move on to another example. Find the second derivative if you have this equation given here, and you can see that this is an example of implicit function where you can express y on the left side and x on the right side easily. So what we can do is we can find the derivative of this function by using the process explained in implicit differentiation. Okay, so that's what we're going to do, and let's start off with finding the first derivative, which is y prime, and that is equal to the process of differentiating the left hand side with respect to x, and differentiating the right hand side also with respect to x. And so what we're going to do is we can separate this part here. So we have x to the power of 4 plus this one, this one is x, y to the power of 4, and the result here is going to be 0 because 16 is a constant. So here when you differentiate this one, this is straightforward. The result is going to be 4x cubed plus, now on this part here, we are going to apply the chain rule method. So this is the outer function. The result is going to be 4y cubed multiplied with the result of differentiating the inner function. Now y is some unknown function, so when you differentiate that, the result is going to be equal to dy dx. Okay, and this one is going to be equal to 0. Okay, so next is we can find what is dy dx. Dy dx. Okay, so for y cubed, dy dx is equal to negative 4x cubed. Therefore, dy dx is negative 4x cubed over 4y cubed. And this is just negative x cubed over y cubed. So that's just the first part of finding the first derivative. Now we're going to move on and use the result here in order to find the second derivative. Okay, so let's do this. So in order to find the second derivative, okay, this one, so we are going to apply the same idea, which is we are going to differentiate both parts here with respect to x. So here we have d dx, dy dx, yeah. This is equal to, differentiate that with respect to x, negative x cubed over y cubed. Now negative 1, this is negative 1, can be taken out. So this is equal to negative 1. This one is differentiate the function here with respect to x, yeah. Right, now I hope you can see that this can be assumed to be equal to f. This can be assumed to be equal to g, and you can apply the formula, which is g f prime minus f g prime over g squared, in order to solve the derivative of this function. Okay. Right, so that's what we're going to do. So here we will have negative 1. Now g is y cubed. If you differentiate f, you will get equal to 3x squared minus, now f is x cubed. If you differentiate g prime, now again here we're going to apply the idea of chain rule method. This is outer function, so you differentiate that, you will get 3y squared, and this is going to be multiplied with derivative of the inner function. So y is a function. If you differentiate that, you will get dy dx, yeah. Okay, over g squared. So g squared is y cubed, and you square it, so you will get y to the power of 6. Okay, right, now let's just try and simplify that. Okay, so we have so negative 1, so here we have negative y cubed 3x squared plus negative 1 here, so you will have plus x cubed 3y squared dy dx over y to the power of 6. Okay, Now just notice that on the left hand side here, this part here is equal to, this is just the second derivative. We don't need to do anything with this. This basically means you differentiate the result of that first derivative, and that is the result of second derivative, which is y prime. So we don't need to do anything with this left hand side. Yeah, this is just the same thing as using the operator d squared y dx squared. So this is the notation of the second derivative, really. Right, now we're just going to continue with this. We're just going to simplify the process here. Now dy dx, we can substitute here the result here. We can substitute this one here into dy dx. Yeah, so that's what we're going to do next. We will have negative y cubed 3x squared plus x cubed 3y squared, and over here we have negative x cubed over y cubed, y to the power of 6. Okay, so what else can we do? So let me just write down this clearly. This is y cubed. Okay, I'm just going to erase this part, and so that we have some space to continue our work. Okay, so now let me just rearrange what we have here. So I'm just going to rearrange and simplify what we have here. So that becomes, so therefore what we have is, we have negative 3x squared y cubed. Okay, this one just writing it down differently, negative 3x squared y cubed. And over here we have negative x, so x cubed times with x cubed, we get x to the power of 6. 3 is here, let's say y squared over y cubed, so you will have over y, right? This one can be cancelled, so you get negative 3x to the power of 6 over y, and here we have y to the power of 6. Okay, just simplifying the top part here. Now what I'm going to do is, this one here is going to be equal to, I will have the same denominator for this two expression here, so I will have over y. So on this part here, I'm going to have negative 3x squared y to the power of 4 minus 3 to the x to the power of 6 times with 1 over y to the power of 6. Yeah, I'm just rewriting this expression in this manner, and based on that I have negative 3. I'm just going to factor out negative 3x squared. Yeah, so negative 3x squared. Inside here will be left with y to the power of 4 minus x to the power of 4. Sorry, plus, because negative 3 is out, so here it becomes plus over y. This is you can see that y times with y to the power of 6 is going to be y to the power of 7. Okay, now I hope you can see what's going on here. Now what we can do is, we can replace y to the power of 4 plus x to the power of 4 with this value, which is 16. Okay, so here we have negative 3x squared 16 over y to the power of 7, and this is going to be negative 48 x squared y to the power of 7. Okay, so that's the answer to example 3.18. Alright, let's move on to this example. This is the last example which I'm going to show on this video here. You are asked to find the 27th derivative for this function. Okay, now in order to see what's going on, we can start with finding the first derivative. Okay, so the first derivative is f prime x, and that is equal to differentiating cosine of x. If you differentiate cosine of x, the result is going to be negative sine of x. And we can continue with the second process of finding the second derivative. This is going to be equal to apply the result of the first derivative here, and you will get that the answer is going to be negative cosine of x. Next is we can continue with finding the third derivative, and this is done by applying the result of the second derivative into here, and you will see that the result here is going to be equal to sine x. Finally, what we can do is we can continue on with the fourth derivative, and this will be done by applying the result of the third derivative into here, and if you differentiate this function, the result is going to be equal to cos x. So now if you continue on for the fifth derivative, this is obtained by supplying the result here into this, and the result is going to be negative sine x. And you will see that for this part here, you go back to the original point of finding the derivative for cosine of x, where you get the same answer really. And you can see that by doing this, the process is going to repeat itself. So here we have a cycle where the whole process here is done or repeated after the fourth step. So here is the cycle. This is the complete cycle. Every 4 steps you will get the same answers again, and therefore we can see that for 27, that means you're going to differentiate it 27 times. You can imagine that the process is going to be something like this. You can imagine that from the derivative, the fifth derivative, the 6th, the 7th, the 8th, you will get the same result as given here. You get the same result as given here, which is 5 for this one, 6 on this one, 7 and 8. Yeah, so therefore what you can do is, I'm sure you'll be able to process the whole thing, where you will see that 25 for the 25th derivative, 26th derivative, 27th derivative, and the 28th derivative, this is the cycle that is associated with this cycle and this original cycle here. And you can see that for that particular question that we're interested to find, which is the 27th derivative, the result is going to be this one here, which is sine of x. Okay, so here with this manner of constructing the idea, you can see that therefore the 27th derivative cosine of x is going to be equal to sine of x. So this part here requires some explanation, and I've already explained to you why is that so, because we have the cycle every 4 steps, the answers are just going to repeat themselves, and we know that we have this cycle here for 25, 26, 27, 28. Therefore the answer for this one, which is the 27th derivative, is going to be equal to sine of x. Alright, I think that's all for now. Thank you very much for watching.